everybody. In this video, I will talk about the Python program to check whether a given number is prime or not. Okay, prime number are those numbers which are divisible by itself and 1. Let's suppose 7 is a number we want to check whether it is prime or not. So what we do is we'll take all the numbers between 1 and 7. The numbers between 1 and 7 are 2, 3, 4, 5, 6, and we'll check if any one of these numbers divides 7 exactly or not. Means when 7 is divided by any of the numbers between 1 and 7 and we get remainder 0, then 7 is not prime, otherwise 7 is prime. Now let's write the simple logic here. 7 I is equal to 2. Now let's use the while loop. While I is less than num. Okay, we will be checking if this num is divisible by I or not. Is equal to 0, then break, we don't need to check further, else I will display the value of I here, and then I will increment the I by 1. Okay, simple. Now what I am doing here is I'm trying to see if any number between, okay, I will write in comment, if any number between 2 and 7 divides 7 exactly or not. Okay, if we find any one of the numbers between, hash is the comment sign, 2 and 1 and 7, 1 and 7, then 7 is not a prime. Okay, simple. I have to mention this as a 2, 1, 1 and 7. If any number between 1 and 7 divides 7 exactly or not, we have to check this. Okay, then if any one of these numbers that lies between 1 and 7 able to divide 7 exactly, then 7 is not prime. So same thing I've coded here. Here initially the value of I is 1, 2, and I checked if 2 divides 7. If it is false, I will be taken to the else part. In this part I'm displaying the value of I and displaying I by 1, incrementing I by 1. The value of I will be now 3. Now 3 is less than 7. 3 will divide num, and to check if the remainder is 0, we know that when 7 is divided by 3, we will not get remainder 0, so this break will not be executed. We will be taken to the else part. In this way the value of I will go up to 6, and 6 when divide 7, in that case also we will not get the remainder 0, so the will be taken to the else part and the value of I will be incremented and it will be 7. Now 7 is not less than 7, so the loop will be terminated. Okay, now let's display the value of I here. I after loop I. Okay, after loop, what will the value of I? Now if the value of I is equal to num, then what we have to say, the given number is prime. Otherwise given number is not prime. This condition, if will be evaluating to true only when none of the numbers between 1 and 7 is able to divide this given number. Okay, so when none of the numbers between 1 and 7 is able to divide num, and when loop terminates, the value of I will equal to the given number. So if the value of I is equal to the given number, in that case that number is definitely a prime, otherwise that number is not prime. Okay, now let's execute this, run module. Now we can see after loop it is 7, so 7 is equal to 7 and 7 is a prime. How many times this loop ran? 2, 1, 2, 3, 4, 5. That means 6 times, 5 times this loop iterated. Okay, now let's give some other number, 15. No, 15, I think I should give 25. Okay, we know that 25 is not prime because 5 divides 25. There is a number except 1 and 25 which divides 25 exactly, and that number is 5. So this is not prime. Now let's see what our program says. Now okay, not prime. 5 is divided by 2, divided by 3, divided by 4, but when it is divided by 5 we get the remainder 0. So this break is executed, so we are not taken to the else, so we are not viewing this value of I here, but after the loop we can see the value of I is 5. So here what we are doing is we are checking if the value of I is equal to num. Here I is 5, num is 25. So 5 is not equal to 25. We are taken to the else part and we are displayed it is not prime. Okay, this is simple logic to check whether a given number is prime or not. But this algorithm is very time consuming. If the value of num is very big, suppose like something like this is very big, so how many times that while loop will iterate it? It will iterate for a huge number of time. So what we can do to reduce the number of times is we can take the square root of given number. Instead of running this while loop up to the given number, what we do is we'll take the square root of given number using the math.square root method of the Python. Then we will convert that number or cast that number into the integer. To use the math square root method of math module, I have to import this math module using the import keyword. That is the inbuilt module of the Python. So we will be using the keyword import to import the math module. After importing this math module, we can use this square root function. Here if the number is okay, now let's suppose 11. Okay, we know that 11 is a prime because there are no other numbers from between 1 to 11 which divides 11 exactly. So 11 is prime. When we take the square root of this number, we will get 3 point something something something. So that 3 point something something should be casted to the integer. So I am using the int method to convert that real number into the integer. So that value will be 3. Okay, this value will be 3. Okay, I have to write this, change it here also. Okay, what I can show this. Okay, suppose okay, print sqrt of 11 math dot sqrt num. We have assigned 11 to the num, so I can write num print after casting int math.sqrt num. Okay, one more bracket I need. Okay, fine. Now what I'm doing is I'm taking the square root of num and displaying it, and then after that I'm casting that value to the integer. Same thing is happening in the while loop also. That means when you take the square root of num and use in this loop, the number of iteration will be reduced. If you do not take square root and left just num like in the previous situation, that loop will run for 9 times because the value of num is 11. 2 to 10 it will execute, and when value of I becomes 11, loop will terminate. That means it will execute 9 number of times. But when we take the square root of this number 11, that loop will iterate for only 1 or 2 times because the square root of 11 is 3 point something, and we cast that float real number to integer into int method of the Python. That will return us 3. 2 is less than 3, so that iteration executes for only 1 times. So in this way we can reduce the number of iterations. Now let's execute this. You can see prime 11 is prime. You can see the loop iterated only once. After the loop the value of I after the loop is 3. Now we can change this to some other number like 113. Let's check whether this is prime or not. Run module. Now prime. That iteration, the number of iteration is 1 2 3 4 5 6 7 8. Only 8 number of times that loop iterated. So in this way, by taking the square root of given number to execute the loop, we can reduce the number of iterations. That is efficiency. We are trying to increase the efficiency of this algorithm. Okay, so in this way we can use the simple logic to check whether a given number is prime or not. Okay, thank you very much for watching. Thank you very much. Well,